Hi, this is Isaac Pint, and for my term project for ECE 376, I decided to do a hearing test. So the question I had going into this project was whether or not I could detect a difference in frequency, just in general, how small I could go with still getting accurate results. Um, there was an example in class of a group that did a difference of 5 hertz, and I thought that was a little bit too easy, and that I would have no wrong guesses whatsoever. So I did 2.5 hertz. So my question is, can I here detect a difference in frequency of 2.5 hertz? And if so, how accurately can I do it? So my hypothesis ended up being using the PIC processor, I'll be able to accurately detect an audible difference of 2.5 hertz played over a speaker without the possibility of the outcome being affected by lucky guessing. So the design for this was to set up a PIC board with a speaker and to have it randomly play one of two tones. And as I mentioned, um, the tones had a difference of 2.5 hertz. These two were chosen to be 392 hertz and 394.5 hertz. Um, and then to record the results, you would guess which tone was played by pressing either RB0 or RB1. And then once you do that, it'll detect if you were right or not and record that on the LCD. I decided to do a sample size of 200. I thought that was a good number. And once I did that and had my data, I would record a chi-squared value based on those results and kind of find the probability that the numbers were accurate and they weren't affected by lucky guessing or anything of that nature. Um, the C code that I use for this is right here. I use two interrupts, one for RB0, one for RB1. I used a timer and timer one compare, and the timer one compare was to set up the frequencies accurately, so that I knew I was getting accurate frequencies. So I calculated out what value of n I would need here in the while loop. So for 392 hertz, n was 12,755, and for 394.5 hertz, n was 12,674. And so basically, how I set it up was that my x value would be determined randomly based off of the timer. Um, it would then play the base frequency of 392 to give you a base, and then your random generated frequency would be played shortly after that. And then once you did that, depending on what button you pressed here, it would record if you were correct or not, and then display it on the LCD. So it would display how many correct, incorrect, and the total number of runs that you've made. So this is my demo of the project and kind of how I had it set up and how it worked. When you click RB0, it'll play your first tone, and then from there, clicking RB0 or RB1 will record whether you were right or wrong from the previous tone that was played. Um, I'm not sure how this is going to save this video, or as a video or a PowerPoint, but I have the link on the PowerPoint and on the report document. So if you can't get it to play on here, uh, just opening the link should work. For the data and statistical analysis, it's pretty straightforward. I had, out of 200 total runs, I had 197 right and 3 wrong. For calculating the chi-squared value, I just selected 5 as my expected frequency for how many I'm going to get wrong and 195 for how many I can get right. this might have affected my probability a little bit since I'm kind of just throwing out a number, what I think I'd get wrong. But it ended up being pretty accurate. I ended up getting 3 wrong. So here's my calculations for how I got my chi-squared value. I ended up with a 0.8205 value, and then with 1 degree of freedom, since we're doing 2 bins, I got a probability of 64% that I was coming by these numbers just from luck and getting it right because of luck, or some other way like making it up. But I think that's pretty good because it needs to be pretty. That percentage needs to be pretty high for you to say that it's just luck. So I think that the data came out good for this. In conclusion, to answer my question that I initially stated and to support my hypothesis, I would say that I can accurately detect an audible difference of 2.5 hertz in frequency. I wouldn't say I could conclude it with 100% confidence. My results were good. I think that the expected frequency of doing the chi-squared, of just assuming that 5 out of 200 would be expected, is kind of isn't very good for supporting my claim. I think if I had more data that could give me the actual expected frequency, I think then I could be a little more confident in my conclusion. But it was still good because you couldn't say that it was based on luck after 200 trials, given my probability that I calculated. I think if I were to add on to this project or to do it again, I would compare these results with I would try a smaller difference in frequency, probably about half a hertz, and compare that to these. Um, I think that those results would look a lot different, and then comparing them to these, I could conclude even more confidently that I can detect a difference accurately with a difference of 2.5 hertz. So I had fun with this project, and that's it. Thank you.